Welcome back to AI for Data, where we talk about how to use artificial intelligence to level up our data work. Today we're going to interview GPT-4 and ChatGPT on statistics questions as if we were giving a data science interview. So my credentials here are I have a master's degree in stats from Stanford, and I was a data scientist up to staff data scientist at Facebook and Meta, which is important because if I get things wrong here, you have to know who to blame. All right, so I've got 3 easy questions, 4 medium questions, 3 hard questions, 10 questions overall. We're going to test the stats knowledge of GPT-4. Let's get started with the first easy one. What is the shape of 2 uniform distributions ranging from 0 to 1 added together? This was actually a question asked to me when I interviewed for my role at Meta, and that was many years ago, so I'm sure they're not using it now. But basically what you're looking for is someone realizing that it forms a triangle. This is sort of the first part of the central limit theorem, and we'll see how ChatGPT does. So nothing it's saying here is wrong, but it also doesn't really answer the question. I'm looking, oh, it does, triangular distribution. All right, great job. We're going to move on to the next one. Obviously it can answer more, but why would I need it to? Okay, how can you find the outliers in a data set? This is a broader question, can be answered multiple ways. If I were giving an interview with this question, and it's pretty close to a lot of interviews that I've seen and done, I would be looking for a number of ways, but I would want them to give me something more substantial than a visualization. Which visualization is fine. It's, in fact, better than fine. I would really like this answer, but I want to see something quantitative here. IQR would be the major one that I want to see. Standard deviation is fine, but not enough. So let's see. There we go, interquartile range. Okay, so we're giving me IQR and visualization. This looks like it's already a fine answer, if not a great answer. I'm going to give it a few more to see if it does anything surprising. Z-score. Okay, so what's interesting about this is, unless I'm misunderstanding something, this appears to be a repeat of the standard deviation method. So this is something that, like, if I were seeing an interview, I would be like, what's the difference between those two? And maybe there's nothing, but this is weird, by the way. This appears to be a new bug, the triple cursor thing. Tukey's fences. That's cool. I don't know this method. Robust statistical method, median absolute deviation. I've never heard of a Hampel identifier. That's cool. I'm going to look that up. And it appears to be going for like the A+ answer. This is awesome. Okay, so someone answering this, I'd want to follow up on the Z-score and standard deviation method, so I will. But other than that, that looks great. What's the difference between the Z-score method and the standard deviation method? Calculate the Z-score, how many standard deviations a data point is from the mean. Calculate the mean and standard deviation. Outliers are defined as data points that are more number of certain standard deviations away from the mean. This doesn't seem right. This feels like it's getting it wrong. Sort of spinning its wheels. That said, if I got this whole actual answer in an interview, I would still be very happy. So I would just think that they're nervous. So I'm just going to stop it here. I think it's just, well, yeah. Okay, let's move on to question 3. What is the probability of throwing 2 fair dice with a sum of 6? Just a very basic stats question, right? You just want someone to be able to understand that how to calculate just simple combinations and probabilities. Okay, yep, good. You want to know that there are 36 possible outcomes for throwing 2 fair dice, and then this is a great way to do a simple question like this, is especially in an interview setting, because it's much harder to screw it up, and even if you screw it up, you're showing your thought process. This is probably a little too detailed, but it's fine. Like, if I saw this interview, that'd be fine. Okay, I'm going to stop there and head over to medium questions. So if you run a regression, what should you check to make sure it's theoretically valid? So classic interview question if you have a job that's quantitative, especially one that's looking for economists, junior economists for a question like this, and you're looking for some classic things about what makes a regression theoretically valid: linearity, lack of collinearity, heteroscedasticity. Honestly, if I get a candidate who can even pronounce heteroscedasticity, they're probably on the right track with this sort of question. Homoscedasticity. Right, you don't want heteroscedasticity, you want homoscedasticity. Cool, okay. So it is doing a good job. I'm going to let it answer a few more other things. Okay, Shapiro-Wilk test. This is a really solid answer. So normality of residuals is important, and I wouldn't have known Shapiro-Wilk test off the top of my head. I have seen using QQ-plot. Multicollinearity, that's definitely the basic one. This is actually a really good point that you definitely would want to bring up in an interview, is that you want to make sure that actually, should we be using a linear regression? Do we have the right variables? And outliers are their influential points. That's great. I'm going to stop it here, but this is a very solid answer. Okay, what is a beta distribution? And can you give an example of what it's used for? This would be a question for someone who is expected to do a little bit more stats work, especially in the Bayesian realm. Beta distribution, at least from what I've seen, is very commonly used for the most simple Bayesian work that you can do, because it's just like the most simple example. Let's see what it says it's used for. Highly flexible, can take various shapes. Oh, that's cool. There could be an entire massive series of how ChatGPT can teach us Bayesian analytics, but if you've never encountered the beta distribution, the simplest way to understand it is if you see a Yelp review that has a single 5-star review, do you actually trust that that is a 5-star restaurant? The answer is obviously no. You don't know what that means. 1-star rating is not enough, and then you can say, okay, well, maybe you have sort of is 10 enough? Is 5 enough? What is enough? And you might believe that you actually have a prior belief in the quality of the restaurant without seeing any 5-star reviews, and you can model that sort of with a beta distribution. Okay, let's say that, commonly used, some examples, Bayesian statistics. Okay, great. Estimate and click through. Yeah, this is awesome. I've never heard of this one. Okay, this is obviously this is obviously a 10 out of 10. Let's ask another one. If you apply an L2 regularization to a regression model, what happens to the coefficients? Super classic data science interview question. And if you've never heard of it, L2 regularization means that you apply a penalty to your regression. Instead of minimizing the sum of the squares of the error, you minimize the sum of the squares of the error plus oh man, I'm forgetting now. I think it's the sum of the squares of the coefficients themselves. And what that does is, also called Ridge or Tikhonov, it shrinks coefficients towards 0, but they don't actually reach 0. And the trick here is that there's something called an L1 or a lasso regression, which shrinks them all the way to 0. And that's why lasso, if you shrink a coefficient to 0, you can essentially take that coefficient out of the equation. That's why lasso is useful for making sparse models, whereas L2 is not. Let's see if it does this. Minimizes. It does not force any of the coefficients to be exactly 0 unless they start at 0. So this is a phenomenal answer. I have been asked this, by the way, in a data science interview, and my answer was not as good as this. So great job. What is a good method to pick the k of a k-means clustering. Okay, so how do you pick the number of clusters when you're doing clustering? And there's a few ways to do this. What we're looking for is gap statistic, elbow method, or the silhouette statistic. Here we go, elbow and silhouette. I thought gap was common, but maybe not. Okay, so already, like, basically, back of my head in an interview, I'm going, yep, they got it, it's fine. And because you may or may not remember the specifics of what these mean, but you can sort of, just even knowing those exist, getting 2 out of 3 already puts you pretty high up in terms of value of being able to prove your statistical knowledge. Yeah, this is great, though. I mean, this is way beyond what you would expect, at least for anything that I've seen. Within cluster? Well, actually, I mean, if they're coming right out of grad school, you want to getting a PhD candidate or something, they might be able to do this. Cool. Okay, I'm going to stop it and move on. Let's move on to the hard questions now. What is, back to an L2, what is the Bayesian equivalent of an L2 regularized regression? Again, this is super classic. This is a super classic question, and you want them to say, let's see if ChatGPT can get it. You want them to say that it's equivalent to a normal prior centered on 0. Gaussian with mean 0. Okay, so it got it. Basically what this means is that whole thing that I mentioned before, an L2 regularization, it's equivalent to a Bayesian process where you basically go, nah, I don't trust that these coefficients would be high. My prior belief is that they would actually be 0, which kind of makes sense if you think about it for a little while. All right, another one. What is the approximate probability of throwing 1,000 dice and getting sum over 4,000? So this probably shouldn't be that hard for a computer, but it's something that would be quite hard for a human. It's not trivial, like, because it has to know that what we're asking. It's funny how fast our goalposts adjust. This is amazing. It's absolutely amazing that a computer can understand that I'm asking for the normal approximation to a binomial here. That said, it might be easier than some of the easier ones here, and it's the kind of thing that a human might be able to do, and it's really worth memorizing, in my opinion, if you're interviewing and even on the job. But it's definitely in a hard category. Okay, so what you have to do is realize that what I'm talking about is a normal distribution. Yes, that's right. Sorry, normal approximation. And you have to calculate the mean and the variance, and then use that to output the probability here. Let's see if it's going to figure this out. Okay. Yeah, standard deviation. Great. Okay, yeah, you need to get the z-score. That's the key. Oh, this is so cool. It does that little approximation. Okay, great. Awesome job. Okay, and we're going to ask one more. This is going to be a big one. I'm just going to type it out and talk you through it. Imagine you run, but this is like a really, it's a common, very advanced question. If you run a laundry store, and you wouldn't expect anyone to get the exact answer, just walk you through the process. And you're competing with another laundry store. You want to know how many shirts they're cleaning per week to compare with your own output. All right, so competing laundry stores. You notice that they give each customer 1 ticket per shirt. Their tickets are numbered, have numbers that start with 1, go up consecutively, and start over every week. You randomly find some dropped tickets, 3, 6, and 47 on the ground 1 week. What's your best estimate of how many shirts your competitor makes in a week? Okay, so this is a variation of a classic stats problem called the German tank problem. Wow. And ChatGPT knows that? I wrote this example today. This isn't a reference to any book, any text on the internet. That's unbelievable. But I think it's wrong. The whole point of the German tank problem is that you don't use MLE, right? The maximum likelihood estimator fails in the case of the German tank problem. In fact, the maximum likelihood estimation for the German tank problem is the highest tank number you've seen, which is obviously silly, which shows the limits of the maximum likelihood estimator. In fact, if I remember correctly, I think the most common solution for the problem is called the minimum variance unbiased estimator, the MVUE. And I think it's showing that solution here, although slightly different. So this is an amazing example where ChatGPT does something that's kind of really impressive, but then also gets something wrong, and wrong with confidence. So this has been a classic criticism of ChatGPT and was very much true in 3 and 3.5. This is an example where it still shows up in 4, but it's on the much more advanced end. So overall, how did ChatGPT v4 do? Really, really well. Nailed the easy questions, nailed the medium questions, got 2 of the hard questions right, and got 1 of them partially right, sort of in the ballpark, but generally wrong. So overall, ChatGPT is a phenomenal learning tool for learning the stats part of data science or data analyst interviews, as long as you have points of reference where you can correct it on especially the hard stuff.